Probability. We're going to start with probability looking at single outcomes. These are just events that have just one outcome, not multiple things like drawing a card and rolling a dice and tossing a coin. But these are just starting with single outcomes. Probability measures the likelihood of an event happening. And this can be visualized and measured on a scale from, say, impossible up to certain. So you've got impossible all the way up to certain. So for the following events decides how likely or unlikely they are to occur. So the sun will shine sometime today. Well, that's probably possible. You will win the lottery next year. It's not impossible. There will be 367 days this year. If you plug out the TV, it'll stop showing the program, or it will rain sometime next year. That's pretty likely, I would say. Now, in all cases, the likelihood of an event happening is given by 0 is less than or equal to p, less than or equal to 1. It could be equal to 0. It could be equal to 1. Generally, it'll be somewhere between the two. In addition to the likelihood, in all cases being given by this, the following additional information applies. The sun will shine sometime today. It's possible. Depends on where you're at. If you're talking about Dublin, yeah, it's a good chance today, given that it's the season it is. You will win the lottery next year. It's most unlikely. It's not equal to 0, but it's roughly 0. There will be 367 days this year. That's impossible. If you plug out the TV, it'll stop showing the program. Pretty much, I think, or you'd get very scared. Certain. And then it'll rain sometime next year. That's pretty likely. It's not impossible, but it's up there at the 1, I think. When an operation is conducted, the results are called outcomes. So here's an example. The possible outcomes when throwing a die are 1, 2, 3, 4, 5, and 6. If a bag is filled with 27 red, blue, and green counters, the possible outcomes when selecting a counter are red, blue, or green. The possible outcomes when selecting a card suit from a pack are spade, club, hearts, and diamonds. So we write that as our first formula. You might choose to highlight that with a highlight pen or something, but that's one that comes up quite a bit. The probability of something happening is the number of ways it can happen over the total number of ways, or the number of outcomes meeting the condition over the number of possible outcomes. And the probability of something not happening is 1 minus that, where it either happens or it doesn't happen. So if we add the probability of something happening to the probability of it not happening, that must be 1, because something must happen. It either happens or it doesn't happen. What's the probability it'll rain today? There's a probability. What's the probability it won't rain today? There's a probability. What's the probability it'll rain or it won't rain? It's got to be 1, because it'll either rain or it won't. So write down the sample spaces relating to the following events. Tossing a coin, it's a sample space of H and T for heads and tails. Rolling a die, call it die in the singular for dice. A sample space of 1, 2, 3, 4, and 5, and 6. I've drawn it as a set. And selecting a card from a pack of cards, and I've drawn that here as AC, 2C, 3C, 4C, all the way up to KC, where I've used A for ace, J for jack, Q and K for queen and king, and then the numbers then, and the suits are clubs, spades, diamonds, and hearts. So you can imagine there that 8D that's the 8 of diamonds, the 9 of spades, the jack of spades, etc. And you can see in that set there's quite a lot of terms. There's actually 52 different examples there. Now, here's example 2. Probabilities relating to dice, or die if there's just one. You're actually very good at probability instinctively. So let's look at it before we think about formulae at all, and just say, what do we think? What do we know the answer to be? And then when we know that and we're confident in that, then we can reconcile the formulae and use them more widely. So what's the probability of 1 getting a 1 on the roll of a die? Well, you can look at that and you can say, well, there are actually 6 different options here. 1, 2, 3, 4, 5, and 6. And if it's fair, they're all equally likely. So the probability of 1 on the roll of a die, you would say, is 1 over 6. What's the probability of an even number on the roll of a die? You would look and you'd say, well, 2 is even, 4 is even, and 6 is even. Out of the 6, that's 3 out of 6. Similarly, if we were to look at the odd numbers, we would say, well, we've got the 1, the 3, and the 5, and we would get 3 out of 6. Now, if somebody said, what's the probability of an even number or a 1? Well, here you'd go all the evens, the black ones that we mentioned there, but we'd also add in the 1, and that might be 4. And if somebody said odd number or 1, you'd say the odd numbers were 1, 3, 5, or a 1, but we've already counted it. So it's still only 3 out of 6. The reason I did this now was just to ask you to think about the word or. The word or there, even number or 1, added the 2 probabilities and gave you 3 over 6 and 1 over 6 to give you 4 over 6. But in this case, odd number or 1, you had already counted the 1. So or didn't actually make it any better or more likely. So it's just become a little bit aware about what or does. Generally, or makes things easier, but not always, obviously. And it's just to get a sensitivity towards it. Now, we'll do it with the formulae later. But there's the sample space for the roll of a die is given by 1, 2, 3, 4, 5, and 6. Now, given that the sample space is this, what's the probability of the number of outcomes meeting the condition over the total number of outcomes? So this is the formal approach we use. P1 on the roll of a die, you'd say, well, how many 1s are there? There's 1. How many numbers are there? 1, 2, 3, 4, 5, 6. So you'd say, how many numbers in the set of 1 and how many numbers in the set of 1 to 6? It's 1 over 6. The probability of an even number, how many numbers in the set of 2, 4, 6 over how many numbers in this? 3 over 6. Now for the odd number on the roll of a die. The odd number here, or even number, 1, 2, 3, 1, 2, that should be 1, 2, 5, 1, 3, 5. And then the even number or a 1, 2, 4, 6, and 1. So 4 attempts there. And the odd number or 1, still only 1, 3, and 5. So still only 3 over 6 for the odd number plus 1, 4 over 6 for the even number or 1, and for the odd number just 3 over 6. So that's the full formal way of doing that. Now, we now look at examples with cards, and we look at the probabilities there. A card is drawn at random from a pack of 52 cards. Find the probability that the card drawn is either a queen or a club. Now in this situation here, I've drawn the 52 cards again, but I've highlighted here all the ones in red that relate to clubs. They have the second letter for C to say ace of clubs, 2 of clubs, up to king of clubs. So we're looking here now, it's drawn at random, and we're saying it's either a queen or a club. So it either has the letter Q or the letter C in there. Now, in terms of queens, we've got the queen of clubs, spades, diamonds, and hearts. So we've 4 of them. But we've also got 13 clubs. And we're using the word or. So again, there's the actual representations of those. The sample space shows 13 clubs and 4 queens. However, the queen of clubs is represented in both sets, the set of clubs and the set of queens. So this queen of clubs, we can't count it twice because it's in the club set and it's in the queen set. So we calculate the probability using the formula, the number of outcomes meeting the condition over the total number of outcomes. And here we can see that in terms of queens, we've got 4 of them. In terms of clubs, we've got 13 of them. But one of them, which is both a queen and a club, is sitting here. So if we want to work out the total, it's 1 plus this, it's this plus this plus this. So the total number of outcomes meeting the condition is given by 13 clubs plus the 3 other queens. Really 16, not 17. So clubs or queens, number of outcomes, 16 over 52. And we can simplify that. 16 over 52, we can say that 2 goes in, they're both even. So you could say that's 8 over 26. They're both even, 4 over 13, and we can't simplify any further.